Hi, welcome to Division of Fractions. What a loaded topic. I think we'll learn some pretty cool things in this presentation. So, you may have heard a poem that says, "Ours is not to question why, just invert and multiply." What a horrible poem. I hate this. I hope you are not going to pass this terrible thing along. This poem is based on the fact that a lot of people don't understand why we divide fractions the way we do. And I think that's totally the fault of textbooks and math teachers everywhere. There's lots of ways we could do this that would make more sense. We go for the fastest thing and not what will make people understand it better. So I'm going to give you 4 different ways to think about division of fractions. So the first one, y is a over b divided by c over d equal to AD over BC. So the first one is the following. We multiply fractions by multiplying the tops and multiply the bottoms. So why can't we just divide the tops and divide the bottoms? And the answer is you absolutely can do that. You can divide fractions by dividing the tops and dividing the bottoms. Who knew? I didn't know this, and I had a math major. But it makes sense. We don't do this all the time because the division on top and division on the bottom may not come out so pretty. But we could always guarantee it works. We know by the fundamental law of fractions, I can rewrite a fraction by multiplying the top and bottom by the same stuff to guarantee that the division's going to work. I want to divide the top by c, so I have to make sure my first fraction has a c as a factor. I want to divide the bottom by d, so I want to make sure that d is a factor of the bottom. So to make sure that c and d are factors of the top and bottom respectively, I'm going to multiply the top by c and d and the bottom by c and d. So a over b is the same as ACD over BCD, right? If I just use the fundamental law, I could simplify it back down to a over b. But now, looking at a over b as ACD over BCD, I can do easy division. So a over b divided by c over d is ACD over BCD divided by c over d. We divide the tops. A times c times d divided by c. You just get AD left. And b times c times d divided by d, you just get d left. So you get AC over BD, which is what we thought. So here's several examples of dividing fractions by dividing the top and dividing the bottom. So let's start with ones that turn out pretty well. 5/18 divided by 1/6, that's 5 divided by 1 over 18 divided by 6. 5 divided by 1 is 5, 18 divided by 6 is 3, and so you get 5 over 3. 8 over 15 divided by 2 over 5. Do 8 divided by 2 on the top. The top is 4. Do 15 divided by 5 on the bottom, that's 3, so the answer is 4 over 3. And another one that turns out pretty, 7/12 divided by 1/3, that's 7 divided by 1 on the top, that's 7. 12 divided by 3 on the bottom, that's 4, so the answer is 7 over 4. So what do you do when you want to divide the tops and you want to divide the bottoms and it's not so pretty? Well, we're going to use that fundamental law of fractions I mentioned earlier. I'm going to multiply my first fraction, that is the dividend, by the numerator and denominator of my old fraction. We're going to do this because that will make the division easier. Take a second if you want to read and catch up, and I'll see you at the next slide. So, first example, I have 2/5 divided by 3/4. To make 2/5 divisible by 3 on the top and 4 on the bottom, I'm going to multiply top and bottom by 3 and then by 4. So the top is 2 times 3 times 4, When I divide by 3, that undoes multiplying by 3. I get 2 times 4. On the bottom, I have 5 times 3 times 4. I divide by the 4. That leaves me the 5 and the 3. So 2 times 4 is 8. 3 times 5 is 15. 2/5 divided by 3/4 is 8/15. Let's do another one. 12/17 divided by 3/5. I want to make sure that the top is divisible by 3 and the bottom is divisible by 5. Now, to be honest, I could just skip multiplying top and bottom by 3 because 12 is divisible by 3 already. But just to be a little bit more robotic, I'll go ahead and multiply everybody by 3, top and bottom, and 5, top and bottom, so that the top is divisible by 3. I get 12 times 5 when I multiply by 3 and then divide by 3. And on the bottom, I multiplied by 5, but then I divided right again by 5, so I'm left with 17 times 3. So I get 60/51. Now, that's not in simplest form because both of those are divisible by 3, but I'll leave that to you. So maybe you don't love the fundamental law of fractions idea. Let's try another one. Let's divide using common denominators, right? We add using common denominators. We subtract using common denominators. Why couldn't we just divide using common denominators? So let's do that. So I have an example, 2/3 divided by 3/4. Let's get common denominators of 12. So 2/3 is going to become 8/12. And 3/4 by multiplying top and bottom by 3, that's going to be 9/12. And now 8/12 divided by 9/12, that's asking the question, how many 9/12 fit into 8/12? Well, I guess 8/9 of 1. So the answer is going to be 8/9. Or you could just kind of think the way we had it before. I could divide the tops and divide the bottoms. 12 divided by 12 is 1. The top is 8 divided by 9. So the answer is 8/9. Let's do some more using this idea of common denominator. 3/4 divided by 3/2. I'll get a common denominator of 4. 3/4 is already having a denominator of 4. 3/2 I can change into 6/4. So I now get 3/4 divided by 6/4. The bottom is just a 1. The top is 3/6. So 3/6 is our answer, or simplify to 1/2. Or how about 3/4 divided by a 1/6? I get a common denominator. The least common multiple of 4 and 6 is 12. So I am going to make my denominator 12. 3/4 is now 9/12. 1/6, multiply top and bottom by 2, it's 2/12. So I now have 9/12 divided by 2/12. 2 will go into 9 4.5 times, or 9/2, 9/2. All right, so we can divide the tops and divide the bottoms just like we multiply across the top and across the bottom. We can get a common denominator just like we do when we add or subtract. That's also a more logical way of thinking why division works the way it does. But let's look at another way. Now remember back when we were talking about whole numbers, we said that 12 divided by 3 is equal to 4 because 4 times 3 is 12. This should work with fractions too. So if I say that a/b divided by c/d is something, then c/d times that something had better give me a/b back. To figure out what that something is, we need to multiply on top by a because I want to get an a in my final answer. I'd better multiply on the bottom by b because I want a b in my final answer of c/d times something is a/b. I've got to get rid of the c. That means I'd put a c on the bottom to cancel it out or simplify out. And I need a d on the top, so I'll have a d over d, which by the fundamental law of fractions is really just not contributing anything. Let's see using numbers. 2/3 divided by 3/4 is something, means that 3/4 times that red question mark has to give me 2/3 back. What fraction would you put in for that question mark? Well, that red fraction needs to do two things. We need to kind of compensate for, get rid of that 3/4, and I need to put in 2/3. You might think for a minute, what would I put in for that red fraction? Otherwise, the red question mark. We'll go to the next slide. To put in the 2/3, I need a 2 in the top, I need a 3 in the denominator. To get rid of the 3/4 on the left side, I need to multiply by a 4 on the top to compensate for the 4 on the bottom, and I need to put a 3 on the bottom to kind of simplify out that 3 on the top. So that question mark, the answer to our division problem needs to be 2 over 3 times 4 over 3, or 8 over 9. Let's check and make sure it works. So I'm taking 3/4. If I multiply by what we just figured out, 2 times 4 over 3 times 3, I'd better get 2/3 as an answer. So on the top I have 2 times 3 times 4, just put them in order. On the bottom I have 3 times 3 times 4. Now by the fundamental law of fractions, I can get rid of those common 3 on the top, 1 on the bottom. I can get rid of the common 4s as factors. The 4 over 4 is really 1, and all that's left is 2/3. So the quotient really is 2 times 4, or 3 times 3, or 8 over 9. So this is to explain why we just invert or multiply. Okay, if 3 methods weren't enough, here's a fourth one. If you were a mathematician who was doing graduate work or was a professor, the way we would explain that dividing is just multiplying by the reciprocal, we would say, well, multiplication and division are inverse processes, and so dividing is just multiplying by the multiplicative inverse, that is the reciprocal. As an elementary teacher, I think this is a lame I told you so kind of explanation. And if that's the only thing you can explain to students, they are not going to like it. And you are not going to be doing what you really need to do to help these students understand. So I hope that that is not what you'll do. I hope you'll learn all of these methods because you may need to know them, I don't know, on a test or something, but also because different students respond in different ways. So the more tools you have at your hand, the better things will go.